Hello dear students, once again welcome back to our channel. I am your maths teacher CG ma'am. In this video we are going to discuss exercise 3.6. It's very important exercise. We can definitely expect one question from this exercise for the board examination. Okay, let us see. See here, solve the following pair of equations by reducing them to a pair of linear equations. Okay, that means here the given equations, that pair of equations are not in the general form of pair of linear equations. So that we have to first reduce them into a pair of linear equations in two variables. Then only we can solve the given equations. The question is clear, that is what is given, pair of linear equations by reducing them to a pair of linear equations. Okay, see the question, 1 by 2x plus 1 by 3y is equal to 2. 1 by 3x plus 1 by 2y is equal to 13 by 6. Okay, here the variables x and y, and is the same variable you can see in the second equation also, but here see the position of the variables in the given equations. Okay, see here in the first equation x and y are in the denominator. Second equation also x and y are in the denominator. But what is in the general form? In the general form of pair of linear equations in two variable, you can see x in the numerator, not in the denominator. See, this is the general equation, a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. See the x and y not in the denominator. So we have to reduce this given equations into this form. Okay, so this is very important. How we can reduce or how can we make this equation of this type? Okay, that means here 1 by 2x. What is 1 by 2x? This can be splitted in this form, 1 by 2 into 1 by x. Okay, so that means here this 1 by x, for that single fraction you have to give a variable. That is 1 by x you can substitute as, if you can substitute this 1 by x using another variable other than x and y, like a or b or pq or uv, that doesn't matter. Okay, but definitely you have to represent 1 by x with another variable other than x. Okay, that's all. So 1 by x is equal to u. I am taking u. Okay, so what happens, children? This 1 by 2 into 1 by x, in place of 1 by x we are going to substitute u. Okay, that means 1 by 2u. So 1 into u, that is u by 2. Okay, after substituting this 1 by x as u, that first term of the first linear equation is reduced in the form u by 2. Why? Because 1 by 2x is 1 by 2 into 1 by x, and we are giving substitution for 1 by x as u. Hence, we can easily make this variable in the position, that is in the numerator. Okay, the constant, the coefficient is whether in the numerator or denominator, that doesn't matter. The only condition is the variable should come in the numerator, should not be in the denominator. That point is clear, children? Okay, the same way 1 by 3y. 1 by 3y can be splitted in the form 1 by 3 into 1 by y. So what to do? Instead of 1 by y, we have to replace, or we have to replace 1 by y into another variable. That is, I am giving substitution for 1 by y as v. Okay, by applying the same idea, that means 1 by 3y, 1 by 3y. Okay, because of 1 by 3 into 1 by y, I am going to substitute this 1 by y as v. So 1 by 3 into v. Okay, in place of 1 by y, v. So this reduced in the form v by 3. Okay, numerator into numerator. 1 into v is v and by 3. That means 1 by 3y is reduced in the form v by 3. See, v is now, the variable is now in the numerator. Understood? The same way, see children, see 1 by 3x, 1 by 3x, you can write this 1 by x as u. So 1 by 3x, okay, is equal to u by 3. Let us see children, 1 by 3x equal to 1 by 3 into 1 by x. Okay, so 1 by 3 into u, in place of 1 by 3, I am substituting for u. That means u by 3. Okay, this is 1 by 3x can be replaced in the form u by 3. Okay, so u by 3, and here also 1 by 2y is equal to 1 by 2 into 1 by y. But what is 1 by y? Is v. Okay, so 1 into v, v by 2. So in place of 1 by 2y, you can write v by 2. Hence, you can reduce the given pair of equations into pair of linear equations in two variables. That idea is clear, children? Okay, that is what we are going to write. In the next step, 1 by 2x. 1 by 2x. What is 1 by 2x? U by 2 plus 1 by 3y. 1 by 3 into 1 by y. 1 by y we have given as v. So, v by 3. Okay. And that is equal to 2. Constant, there is no change in the RHS. Okay, our aim is to replace that variable in the denominator into numerator. That's all. Okay. So, 1 by 3x. Okay. So, 1 by 3x is replaced as u by 3 plus 1 by 2y. 1 by 2y we have seen, that is v by 2. v by 2 equal to 13 by 6. This side is clear, children? Okay. Now as usual, see children, here you can take cross multiplication and you can reduce this in the form of the general equation of pair of linear equations in two variables. Okay, that is the next step. Okay, so I am going to cross multiply. Okay, that is, see children, so u by 2 plus v by 3, isn't it? So 3u plus 2v by 6 equal to 2. First equation. Okay, and the second equation, that is 2 into u, 3 into v whole divided by the product of the denominator. That is the rule of cross multiplication. Okay, since they are unlike, the denominators are different. So you have to do in this way, that is cross multiplication. Okay, so you will have 2u plus 3v divided by 3 into 2, 6, and that is equal to 13 by 6 in the RHS. Okay, yes. Now again, see here you can see denominator, but in the general form, there is nothing is there in the denominator. So we can easily take this 6 to RHS, that is, hence this reduced into 3u plus 2v, and 6 is going to this RHS. This is under division. So when it is going to RHS from LHS, this will go along with the 2, that is under multiplication. So 6 into 2 is 12. Okay, and hence in the next step, see children, here 1 by 6, here also 1 by 6. You can see 6 in the denominator. That is why I explained that as 1 by x, that is 1 by x, 1 by x, or x6 from the denominator can be cancelled. Okay, so 6 get cancelled. So 2u plus 3v equal to 13. It is clear. This is very, very important. If anything is common in the LHS and RHS part, you can reduce them. Okay, this is only possible when both having LHS and RHS having only one term. Here 2u plus 3v by 6. It's a single fraction. Okay, even if numerator having two terms, that doesn't matter. This is a single term that is as together, that is in terms of fraction. So 6 and here 13 by 6. Okay, so 6 can be cancelled. So this is very simply you can get without doing the cross multiplication again. So 2u plus 3v is equal to 30. See children, so this equation now is in the form 3u plus 2v is equal to 12 and 2u plus 3v is equal to 30. Understood? Just like the general form of pair of linear equations in two variable a1x. X is in the numerator. So here in place of x we have another variable. Here in both equations we have kept that variables in the numerator. Understood? So it satisfies the general form. So now we can solve using any one of the method, either substitution method or elimination method. Okay, but elimination method would be better. So in elimination also you can, this is of the different types you can solve. Okay, but here our aim is elimination means you have to eliminate one of the variable. How we can eliminate? We can eliminate one of the variable only when both having same coefficient. Same variable with the same coefficient and different sign. These are the three conditions. Okay, so same variable, same coefficient, different sign. Then only by adding that term will get cancelled. Understood? So children, here we can see there is no common coefficient for either u or v. Okay, in the first equation that coefficient of u is 3, here coefficient of u is 2. Here also the same. So we have to make them equal. Understood? Okay, if both having the same coefficient, you can easily get the value of u and v. But here what happens? Here in the both equation, here either u or v have no common coefficient. Okay, so we have to first make them same coefficient. Okay, that is what we are going to do. Okay, so this is the pair of linear equations in two variable after substituting 1 by x as u and 1 by y as v. Okay, and next step is solving part. So I am giving this as equation number 1 and this is equation number 2. Okay, so this is the way children to make the coefficient the same. I am going to make the coefficient of u. You can make the coefficient of u or v the same. That doesn't affect the value of u and v. Okay, but I am going to substitute for, I am going to make the coefficient of u the same. Okay, for that this is the rule. Equation 1 should be multiplied with the coefficient of u in the second equation. Okay, that means I am going to multiply not only the first term of equation number 1, the whole terms, both LHS and RHS. Okay, so this equation 1 now becomes with 2. So 6u plus 4, 2 into 2, 4v is equal to 12 into 2, 24. Okay, and so 6u plus 4v is equal to 24. This can be equation number 3. Okay, and see the next step. I am going to multiply equation 2 with the coefficient of u in the first equation. Children, don't confuse this step. Okay, then only you can make the coefficient of u the same. Understood? That means coefficient of u in the first equation is 3. See children, what I have done? I have multiplied equation 1 with the coefficient of u in the second equation and we got this equation, equation number 3. And the second step you have to multiply equation 2, the whole equation, that means each term both in LHS and RHS with the coefficient of u in the first equation. That is the indication I have written here. So equation 2 should be multiplied with the coefficient of u in the first equation. Okay, so hence it becomes 3 into 2 into 3. Equation 2 with 3. Equation 2, the first term is 2u. 2u into 3, that is coefficient into 3, that is 6u plus. Then 3v into 3, 9v is equal to 13 into 3. Okay, RHS also multiplied. Okay, that is 39. 13 into 3 is 39. Now see children, we have now new equation. Okay, pair of linear equation having coefficient of the first variable, that is u the same. That is 6u, 6u. Okay, don't look into the coefficient of v. We made the coefficient of u the same first. Okay, so that you can easily solve u as well as v. Okay, now what is the next step? The next step children, here we have only the coefficient, both of the equation the same. In order to eliminate means we have to cancel. We have to exclude those terms from the equations. For that you have to do subtraction. Okay, that means 6u minus 6u, then only that term gets cancelled. We can eliminate u term from both the equations. That is very, very important. If both the equations having same coefficient with the same variable, in order to eliminate both the terms, you have to do subtraction. Okay, but this is very important. You have to subtract not only these two terms. Okay, you have to subtract this 3 minus 4. Equation 3 minus 4. That is the next indication. That is equation 3 minus 4 implies. Okay, equation 3 minus 4. How can we subtract one equation from the other? Okay, that means we have to change the sign then add. Okay, that means I am going to change the sign of equation 4. Okay, minus and minus. Okay, hence you can easily eliminate 6u minus 6u and 4v minus 9v. 4v minus 9v. How can we subtract like terms? By subtracting the coefficient by keeping the variable the same. That means 4 minus 9. So take the difference. So 5 and its sign is negative. So negative 5v is equal to, same way, 24 minus 39 is 15 and it carries negative sign. 639 is a negative number. So negative 15 or v is equal to negative 15 by negative 5, that is 3. 5 in 15, 3 times. You can reduce 13 with 5. Okay, or you can directly cancel negative sign from both sides because both having single term. So that from both the terms negative sign get cancelled, or you can do in this manner also, that doesn't matter. So hence we got the value of v as 3. Okay, and what is the next step? We have to get the value of u also. When we eliminate u, you are getting the value of v first. Okay, when we eliminate v, we can eliminate v and you will get the value of u. Because the eliminating term will not be there after elimination. So the remaining variable is v, hence we got the value of v as 3. Understood? Okay, and in order to get the second variable, that is u, what we have to do? From equation 1, you have to write equation 1 with respect to u, because we need the value of u. Okay, from equation 1, what is that? That is, you can keep 3v alone and you can take this 2v to RHS. So plus 2v become minus 2v. 12 is already there. Okay, so 3u, I am keeping 3u, the term containing the variable u in LHS part, by taking this 2v into RHS. 12 is already there, so you have to write that term first, then this minus 2v. Okay, so in the next step, I can substitute for v as 3. 12 minus 2 into value of v is 3. that is 12 minus 6 and this is 6. This is 3u, not u. Okay, from this you will get, that is, this is 3u, or u is equal to 6 by 3, that is 2. Now we have v as 3 and u as 2. But what we need, we have to solve the given equation. In the given equation, the variables are x and y, not u and v. So we have to resubstitute. What we have taken? We have taken the value of x, 1 by x as u. We substituted 1 by x as u. So from that you can easily calculate the value of x. Okay, our aim is to calculate to get the value of x. For that you have to resubstitute in the first step, that is 1 by x is equal to u. Okay, that is the next step. We have v as 3 and u as 2. Okay, and we have what is it? We have 1 by x is equal, this is a substitution we have given in the first step, okay, before solving. Okay, so from 1 by x is equal to u, what we need x. So x is equal to 1 by u. U will come to denominator, so that x will go to the numerator. So x is equal to 1 by u, that is u is 2, so 1 by u is 1 by 2. Okay, and what is the second one? We have taken as 1 by y. Okay, 1 by y we substituted by v. So hence y is equal to 1 by v. Okay, from this y is equal to 1 by v, and y is equal to 1 by v, or y is equal to 1 by 3. So we got the values of x and y as x comma y is equal to 1 by 2, 1 by 3. Okay, this is clear, children. This is all about the first problem. Now we are moving to the second question. Now we are solving the second question. Okay, here also you can see two equations, pair of equations, but this is not in the form of pair of linear equations in two variables. Why? Because here also you can see that the variables x and y are in the denominators. Okay, see the question, children. 2 by root x plus 3 by root y is equal to 2, and 1 by root x minus 9 by root y is equal to negative 1. Okay, as in the first problem, we are going to give substitution for 1 by root x. Children, this is very important. Don't give or don't substitute simply root x as u. If you are substituting root x as u, what happens? This is again turned into 2 by u. That means the variable is there in the denominator. Okay, our aim is to write the variable in the numerator along with the numerator. Okay, for that this 2 by root x, since 2 by root x is 2 into 1 by root x, you have to substitute 1 by root x as u. So what happens, children? 2 into, as such, this 1 by root x is now reduced into u. So 2u. Understood? So 2 by root x is, now we can write this as 2u plus, the same way 3 by root y, that is 3 into root y. So 3 into 1 by root y. Okay, 3 by root y is 3 into 1 by root y. So we have to give substitution as 1 by root y is equal to v. Children, here also we need not the values of root x and root y, we need the value of x and y, that we will solve towards the end of this problem, how we can get x and y from root x and root y, that I will explain. Now first we have to get the value of root x and root y. That is what we are going to do by giving the substitution for 1 by root x as u and 1 by root y as v. That concept is clear, children. So since 2 by root y, that is 2 into v, Okay, that is 3v is equal to 2. Here what comes, children, for the second equation, 4 by root x is 4 into 1 by root x. So we can substitute 1 by root x as u. So 4u plus, minus 9 by root y. 9 by root y is 9 into 1 by root y, or 9v. Okay, 1 by root y is v. So, minus 9v is equal to negative 1. Okay, this is in the form of pair of linear equations in two variables. That means we have now the variables u and v in the numerator. Okay, now we are going to solve for u and v by elimination method or substitution method. That doesn't matter, but elimination method would be the better. Okay, so children, this is a very another important idea you can apply here. Okay, without without making the coefficient, by multiplying the coefficient of the second equation with the first and second with the first equation, coefficient of the first, you can easily make the coefficient the same. See children, here 2u plus 3v is equal to 2. Understood? Here 4u minus 9v equal to minus 3. Okay, you can, if one of the equation having the coefficients, the multiples of the other, the coefficients of the equations in the second equation, variables in the second equation. Here see children, here 2 and 4, multiple of 4, 2 is 4, multiple of 3 is 9. Okay, you just see the coefficient first. Coefficients plays a very important role in this elimination method. Okay, if the coefficients are the multiples, okay, you can easily make those into the same coefficient very simply. Okay, here fortunately both the u and v having if you see the coefficients, both are the multiples, 2 and 4, 3 and 9. But being u is the first, I am making the coefficient of u of both the equations the same by multiplying equation 1. This is equation 1 and this is equation 2. Okay, if you multiply equation 1 with 2, what happens? Equation 1 into 2 implies. Okay, from where we got this 2? Because to make the coefficient of u in the first equation 4, you have to multiply 2 into 4. Okay, but as I told in the first case, we have to multiply not only for the first term, but all the terms of the first equation. Okay, then only it will again become equation equal to in order to maintain that equivalency. Okay, you have to multiply all the terms of LHS and RHS with 2. Okay, so see children, so 4u that is 2u into 2. This 1 represents equation 1. This 2 is the number by which you are multiplying. Here 2, why? Because 2 into 4. Okay, that is 4u. Now see children, 3 into 2, that is plus 6v is equal to 2 into 2, 4. This is equation number 3. And we are making any change for equation 2 because it is already matched with the coefficient of u in the first equation. That means in the third equation. Okay, that is I am making any change for the equation of 2. That is 4u minus 9v is equal to negative 1. This is equation number 2. No change. So how can we eliminate u? That is 4u and 4u, both are same variable, same coefficient. In order to make negative opposite sign, you have to just subtract. That is 3 minus 2. If you are subtracting 2 minus 3, that doesn't matter. Accordingly, you have to change the sign. Okay, so here in this case, I am going to change the sign of the terms of the second equation. That is minus. Here minus is already there, so this minus become plus and minus become plus. Okay, so 4u minus 4u, the term get cancelled. Okay, 6v plus 9v is 15v. We are adding the coefficients by keeping the variables same. Okay, because they are like. So 6 plus 9, 15v is equal to 4 plus 1. Here negative turned into positive. Okay, so 4 plus 1 is 5 and hence v is equal to 5 by 15, that is 1 by 3. 5 in 5 1 time and 5 in 15 3 times. So we got v as 1 by 3. Understood? Okay, and we should get x, that is u by writing any of this equation 1 or 2 with respect to u. After eliminating u, how can we see the term u again in the equations? Okay, we can't see only v. Okay, equation with a single variable, that is v. That is why we got the value of v first. Okay, now we are going to get the value of u from equation 1. Okay, not compulsory from 1, you can get from equation 2 also. The condition is you should write that equation with respect to the term u. That is here 2u with respect to 2u. Okay, that is from equation 1. Okay, 2u is equal to this 3v should be taken to RHS. Okay, already RHS 2 is there and plus 3v become minus 3v, or 2 minus 3 into what is v? We got v as 1 by 3. So you can cancel, since both the factors are they are connected by into, you can cancel. That is how I cancelled 3 and 3. Okay, so 2 minus 1 is 1. Okay, 3 get cancelled, so minus this 1. Okay, and this is 2u, but we need u. U is equal to 1 by 2. Now we have u and v, but we need x and y. But how we substituted? We substituted for 1 by root x as u. 1 by root x as u. Okay, you can write now 1 by root x is equal to what we got, u as 1 by 2. Okay, and being they are fractions, by taking the reciprocal, root x is equal to 2, or you can cross multiply, you can take this root x into RHS. Okay, that is root x is equal to root x into 1, and 2 into 1 is 2. How will you get x from root x? How can we eliminate root x root sign? By squaring on both sides. What you are doing in LHS, the same you have to do for the RHS also. Okay, don't write this is equal to x is equal to 2. That is wrong. You have to, by squaring on both sides, you can eliminate the square sign from x. Okay, so 2 square. Okay, by squaring only you can cancel the sign, root sign from root x. Okay, so that you have to square the RHS term also. That is 2 square is 4. That is x is equal to 4. The concept is clear, children? Next we need the value of y. For that, how we substituted? We substituted 1 by root y as v. Okay, and what is the value of v? Is 1 by 3. That is 1 by root y is equal to 1 by 3. Isn't it? So as usual, you can take this root y into RHS by cross multiplication or by taking the reciprocal. Both ideas are the same. Okay, which one you feel easy, that you can apply, that doesn't matter. Okay, so root y is equal to this 3 into 1 is 3. By squaring on both sides, you can eliminate that square root sign from y. So squaring on both sides, y is equal to 3 square or y is equal to 9. Hence we got the value of x and y as 4 and 9. 4 for x and 9 for y. This is all about the second problem.